So you could have a limit that goes to infinity. The limit as x approaches a number equals infinity. That means that your y value is getting larger and larger. You could also have it go to negative infinity, meaning your y is getting smaller and smaller. So think about it, if you're approaching an x and your y is just getting higher or lower, what's happening at x? An asymptote, vertical asymptotes. So when you're approaching vertical asymptotes, you'll actually be going to positive or negative infinity, depending on the direction the graph is traveling. It can be one-sided. So this one, as you approach a from the left, it's going to infinity. This one, as you approach it from the right, it's going to infinity. It's possible that one side goes to positive infinity and one side goes to negative infinity, so we can have one-sided and two-sided limits in these scenarios. Okay, let's do some more examples with limits. All right, so on the first one, I'm asking for the limit as x approaches 0 from the right. Why would I say it had to be from the right here? Yeah, that positive, that 0 plus, means you are putting in things bigger than 0. So you are approaching it from the right-hand side. All right, so do you want to make a table or look at a graph? We kind of talked about both ways now. Square root of x, that's an easy one to look at a graph, isn't it? Square root of 0 is 0, square root of 1 is 1. What else can you plug in? 4, 2. Can you do negatives? No, so this is the square root function. So as you are approaching 0 from the right, that means you're coming in on this graph from things bigger than 0. What is that limit? 0. What about as we approach from the left? Can you approach from the left? Does not exist. The graph doesn't even exist when x is less than 0. All right, so we could do a graph here. We graphed rational functions back in college algebra, but there were a lot of steps to that. We could also just make a chart. If you're approaching from the right, you're putting in things bigger than 3. So 3.1, 3.01, 3.001. So if I plug those in, what's happening to these y values?
They're getting closer to 6.
Not to 6. We went from 62, 600 to 6,000 to. They're just getting bigger. So what would this whole thing approach? Okay. So this limit as x approaches 3 from the right is going to infinity. The other direction. So anything smaller than 3. So what's happening to these? So the limit as we approach 3 from the left is negative. Could you plug a 3 into this original equation? No, we have a vertical asymptote there. It's not defined at 3. What if I asked for the two-sided limit on this one? It does not exist because one side is going to positive infinity and one side is going to negative infinity. So the two-sided would not exist. All right. Why don't you guys see if you can figure this one out? So, did you guys plug in these numbers? What'd you get out? So what does this appear to be going to? All right. Let's look at D. So again, you could draw a graph if you wanted, or we could just try our chart. We need things bigger than 3. Okay, so when I plug in 3.1, what happens? Non-real answer. What about if you plug in 3.01? If you graph this, if you put in negative 3, negative 3 squared is 9, 9 minus 9 is 0, square root of 0 is 0. If I put in a 0, you get the square root of 9, which is 3. If I plug in a positive 3, I get the square root of 0, which is 0. This is actually the graph of a semicircle. Does it exist over here? Can you approach 3 from the right? No. So this one does not exist. Next piece. I think I want to skip this one. We'll do more trig stuff later on, but I think I'm going to wait on it for now. All right. So, homework. We've got a lot of class time. I do want to take off problem 35 for sure, or 45 I mean, because I said I'm kind of waiting on the trig stuff. We're going to bring more